Hi everyone, I'm Shreyas and I'm really excited for this series on AI Agents Foundation. I have been in this field of data science and AI for more than 10 years now, and I must mention that you have made a great decision by choosing this topic because AI agents are going to play a huge role in shaping how businesses operate in coming years. One of the best things you can do right now is start understanding how they work so you are well prepared for the opportunities this shift will bring. Throughout my career, I have been involved in multiple machine learning and AI projects. I think I can offer you a valuable perspective because of this reason. In this free course, I will look at AI agents from both technical side and business side, which is exactly the combination that you need in today's AI driven world. Whether you are a business professional, an entrepreneur, or someone aiming to build a career in AI, this course will give you insights into how AI agents are built and how they are used in real world situations. So let us get going. Today, AI has captured the attention of almost every major businesses and tech leader out there. And honestly, the reason is pretty straightforward. Ever since ChatGPT came into scene in late 2022, organizations quickly realized that when used properly, large language models can dramatically boost employee productivity. Tasks that used to take 30 minutes, like writing a well structured email, can now be done in 5. Research that once took days can now be completed in hours. Things like content creation, brainstorming ideas, and fact checking can have become much more faster and far more efficient. And these are just few examples of how AI is already making people more productive. But this is only the beginning. LLMs, they are not just tools that generate text, they can actually reason. They can you can think of them as powerful digital brain, and throughout this series you will see how these capabilities allow machines to analyze situations, make decisions, and perform tasks in ways that start to resemble human like thinking. Now, entrepreneurs have always been obsessed with efficiency and effectiveness. So naturally, once they saw that this what these models could do, the next question was obviously, what if AI could operate on its own? What if instead of assisting human, AI could actually handle tasks independently? And this is where the concept of AI agents come in. When you ask an LLM to write an email, that is a one time standalone task. But an AI agent goes much further. It can connect to your company's database, analyze customer information, decide how different customer groups should be approached, generate personalized email, send them automatically, track open rates and responses, and then improve its strategies over time to get better results. In other words, it does not just execute, it learns and improves. AI agent achieves this by connecting with external tools like databases and email systems and CRMs and APIs and many more. They gather new information, adapt their behavior, and continuously refine their action, very similar to how a human would. And it does not stop at text. Modern AI agents can work with text, voice, video, and even code. And this is possible because of multimodal generative AI and the latest foundational model released by leading tech companies. The easiest way to think about an AI agent is this. Imagine a teammate who works like 24 by 7, never gets tired, continuously learns, and keeps improving over time. And honestly, every business would love to have more teammates like that. For the first time ever, computers and software, they are not just about tools anymore. We are entering an era that is really about skills. And the interesting part is this, that, now we have an agent sitting on top of tools, agents that can actually use tools on their own. That is a huge shift. The potential there is massive. And honestly, we are only beginning to realize how big this could get in coming years. We saw CEOs from Nvidia and Salesforce openly talking about how bullish they are on AI agents. And this is not just a hype or conference talk. These companies are putting serious money behind it. Google launched Gemini 2.0, which is built for this AI driven world. NVIDIA introduced Nemo, a platform that helps companies create their own autonomous AI teammates. Salesforce rolled out Agent Force, and it is already seeing the strong adoption of that. Practically every major tech company now has a flagship agent initiative. There was even a survey by IBM and Morning Consult where 99% of enterprise AI developers said that they are either building or exploring AI agents. The remaining 1%, well, they are probably having a, they are taking up a coffee break. The point is, however, that the, agent era is not coming. It is already here. And this won't just affect the tech, it is going to impact every industry. Some forecasts suggest that AI agents could automate up to 70% of office work over the next decade. Think about that. On one hand, it frees people from repetitive work so that they can focus on solving real meaningful problem that could lead to better products and more innovation. On the other hand, some companies may run leaner teams relying on fewer people who know how to work and work alongside AI agents effectively. In fact, some experts are already calling AI agent manager the job of future, someone who oversees agents, coordinates workflows, and ensures everything runs smoothly. But remember, we are still early. Today's agents are just the first generation. Just like early mobile apps evolved rapidly, agents will keep improving with every new version. They will become smarter, more capable, and far more integrated into our daily work. We have seen this before with the internet in its early days. Nobody fully understood its impact, but over a period of time, internet completely transformed how we communicate, work, shop, and even learn. AI and especially AI agents will define this decade and probably the next ones too as well. So what we could do right now is what you have to ask ourselves. Well, it's simple. Learn, stay curious, and experiment. Keep an open mind because this is one of those once in a generation shifts, and the people who understand and adapt early will be the one who benefit the most. AI agents are designed to perform a wide variety of tasks, and one of their key strengths is their ability to adapt as things change in real time. In other words, they don't operate in isolation. They constantly interact with and respond to their surroundings. This brings us to important question that what do we mean by an environment? Well, an environment is basically everything around the agent that it can observe, interact with, or be influenced by. Different AI agents operate in completely different environments depending on their purposes. Now, let us take a look at the core components that come together when we build an AI agent. We have already talked about environment. This is basically the world the AI agent operates in. The agent uses sensor to observe what is happening around it so it can gather information, understand the current situation. Then comes the model. This is what helps the agent make sense of what it perceives. It interprets the input and forms an internal understanding that the agent can use to move forward intelligently. And then we have the decision making logic. This is the part that decides what to do next. Based on what agent has perceived and understood, it selects the most appropriate action and sends instruction to the actuators, which actually carries out those execution, right? Those action. After that, there's a this is the execution mechanism, which is how the agent's chosen actions get applied to the environment and create real change. And finally, we have this feedback mechanism. This allows the agent to evaluate the outcome of its action and figures out whether it achieved its goal or it needs to adjust its behavior. Understanding these components is really important because they form the fundamental building blocks behind how real agents are designed and implemented in practice. For example, think about a self driven car. Its environment includes the road, nearby vehicles, pedestrian traffic signals, and even weather conditions like rain or fog. As humans, we have learned how to handle this situation naturally because we have experienced them repeatedly. But for a self-driven car, it is not automatic. It has to learn how to interpret all the signals and adapt its behavior accordingly. And since roads are unpredictable, especially in India, with countless possible scenarios, this makes the environment highly complex and challenging. One of the reasons why self-driven car, I think, would not be successful in India. Well, anyhow, now also consider a shopping assistant AI agent. Its environment looks very different. It includes online stores, product listings, user preference, reviews, pricing, promotional offers, and many more. Just like human, it may also consider external world factors such as weather, upcoming seasons, locations, or local events, because this can influence what someone might want to buy. So in many cases, an AI agent's Environment is a combination of digital information like browsing history or product data and real world context like weather or location. The agent's job is to bring all this information together and use it to make smart decisions or recommendation. And that is why designing an AI agent, one of the first thing that you should think about is the environment it will operate in, whether it is purely digital, purely physical, or maybe a mix of both. Because the environment ultimately defines what the agent needs to perceive, learn, and respond to. Now, we don't fully appreciate just how powerful the human brain really is. It constantly helps us observe the world and gather an incredible amount of information. Without even realizing it, our senses are always working in the background, taking in what we see, hear, smell, and experience. All of this information gets processed almost instantly, allowing us to understand what is happening around us and respond in meaningful ways. This ability is what helps us interact smoothly within the world. Now, in AI, researchers are trying to give agents a similar capability, the ability to observe and collect information from the environment. In AI terms, we call this input mechanism sensors. Sensors are essentially how an AI agent receives information from outside world. This sensor they can take many forms. For example, an AI agent might scrape the data from websites, fetch information through APIs, analyze images from the cameras, capture sound through microphones, or just read the data from IoT devices. In simple words, sensors are what allows AI agents to perceive their environment, just like our sensors allow us to perceive the world. Once this information is collected, the agent process it to understand what is going on, decide what action to take next. Take the example of self-driven car once more. Its sensor include things like cameras, lidar, and GPS and connectivity to cloud systems. These sensors help the car understand its surrounding, like where the road is, where the obstacles are, and how to navigate safely. On the other hand, an online shopping AI agent uses different kind of sensor. Its sensor might include web scraper to collect product data, APIs to fetch information, systems that track browsing behavior, price comparison tools, and even external data sources like weather APIs. So overall, the sensors are how AI agents collect information from their environment. They are essentially how an AI agent feels or becomes aware of what is happening around it. But perception alone are not enough. The agent must learn how to interpret what it receives. Just like humans receive information through their lenses, the magic happens in the brain and where that information is interpreted. In AI agents, this role is played by an AI model. The model acts as AI or agent's brain. It takes in raw input from the sensor, it makes sense of it, quote unquote. These models can range from simple machine learning algorithm to advanced neural network and now to large language models as well that can reason in ways that feel remarkably human like. Modern AI models can also handle multiple types of data at once, text, images, audio, video, and this is what we call multi-modal capability. Because of this, AI agents can develop much better context awareness and operate effectively in complex real world environment. So the model layer is responsible for understanding the information the agent receives, but understanding alone is not the end goal. The real purpose of an agent is to take action based on that understanding. And that is exactly what we'll explore next, how agent take decisions. So far, our agent has taken in information from the environment, made sense of it, it has observed what is happening, and analyzed the situation. Now comes the next part, that is deciding what to do next. For that, agent needs some sort of decision mechanism, something that can evaluate different possible actions and pick the most appropriate one. Think of it like suppose you are building an automated trading agent. First, you feed it environment data, thing like maybe stocks, inflation, exchange rate, and other market indicator. Then the agent's model processes all that information. It estimates expected returns, evaluate risk, and basically figures out how promising each investment opportunity is. But the model alone doesn't make the final call. That is where the decision logic layer comes in. This layer applies clear rules or algorithms on top of model's output. For example, you might define a rule that says only consider in that says that only consider investment with a expected return above 7% or a volatility below 15%. So even if the model analyzes everything, the decision layer acts like a checkpoint. It validates the model suggestion against the predefined rule before allowing any action. Let us take a look at another example here, a spam filter agent. So its job is to analyze like thousands of email and classify each one as either spam or legitimate. First, the model looks at the email's content and classify each one as either spam or legitimate. uh, I'm sorry. First, the model looks at the email's content and the things like sender, information, formatting, and other signals. Based on that, it assigns a probability. For example, it might say there's a 90% chance that this email is a spam or not a spam. Then the decision layer logic comes in. It applies a simple rule. If the spam probability is, let us say, greater than 85%, move the email to the spam folder. So here the logic layer converts the model's probability output into a clear actionable decision. In other words, the model gives you a prediction. The decision logic layer turns that prediction into an action. Now, when an LLM is used as an agent's model, things get a bit interesting. LLMs can reason internally. They understand the context, think through options, and even decide what action to take, all within the model itself. So you might consider, do we still need a separate decision logic layer? The answer is it depends on the use case. In many real world systems, having a thin and external logic layer is still very useful. It helps enforce safety, legal constraints, and system rules. For example, imagine an LLM agent trying to improve a financial transaction. Even if the LLM decides that it should approve it, an external logic layer can verify transaction limits, check authentication, or enforce compliance rules before allowing it. This ensures that certain critical constraints cannot be bypassed by the model. In some cases, instead of a separate logic layer, developers guide the LLM using prompt engineering, giving clear instruction on how decisions should be made. There are also techniques like structured reasoning or step-by-step thinking that help the LLM make better decisions internally. So overall, the key idea is simple. The model analyzes the situation, and the decision mechanism, with the external or internal, determines what action should be taken. Now that agent knows how to decide, the next question then is, how does it execute that decision and interact with the environment? And that is what we'll take a look at next. So we have now arrived at a point where the agent actually takes action and starts affecting the environment around it. Think about a few real world examples. Again, a self-driven car moves along the road. A customer support agent sends replies in a chat. An automated trading system places buy or sell orders in the market. In each case, the agent is not passively observing, it is doing something. And once it acts, the environment changes. It creates new information for the agent to observe and respond to. To make this possible, the agent uses actuators. These are basically the mechanisms that let the agent interact with the outside world. Sometimes these are physical, like a robot's arm or the steering controls of a self-driven car. Other times they are virtual, like an API call that places an a stock trade or sends a message. If we connect back to our email example, an incoming email is first processed by LLM, which reads it and converts it into meaningful natural language interpretation. Then the logic layer, the decision layer, looks at that interpretation and decide what should be done next. Based on that decision, the agent interacts with your email system, for example, marking the email as spam or not a spam. If it is classified as a spam, the agent automatically moves it to the spam folder. That's a clear example of the agent taking an action and actively changing in its environment. Once the agent takes an action, the environment changes and the agent immediately observes what happened next. Its sensor picks up the fresh input and new information gets processed and analyzed. Based on this, the agent adjusts and improves how it behaves going forward. In simple terms, when you decide or when you see the outcome of your action and reflect on the consequences, you naturally get better over time, right? Agents work the exact same way. This ongoing cycle of action, observation, learning, improvement is what makes agent more effective because they interact with the environment repeatedly. They constantly get chances to refine their decisions and improve their performance. Let us take a look at this smart thermostat. Initially, it works based on default factory setting, but when you start manually adjusting the temperature, it begins to learn your preferences. Over time, it automatically sets the temperature closer to what you like. Another example is Netflix. When you first sign up, the recommendations are pretty generic, mostly based on what is popular overall. But as you watch more and more content, skips shows or pause or rate various shows, Netflix learns your preferences. Gradually, the recommendation become highly personalized and much more relevant to you. This ability to learn from the feedback and adapt is one of the defining features of AI agent. It is what makes them so powerful. Think of it like improving just 1% every day. It may seem small, but over time, those tiny improvements, those tiny components compound into massive progress. AI agents follow that exact principle: constant feedback, continuous learning, and steady improvement, which eventually allows them to achieve extremely high levels of performance. Previously, we talked about the core building blocks that make up AI agents, the fundamental pieces you need before you can actually design one. Now that you have that foundation, we are ready to move to the next step, that is understanding the different types of AI agent structure. You can think of AI agent structure as different architectural pattern and they vary depending on how complex they are and what they're capable of doing. We'll start with the most basic type, that is the simple reflex agent, and then progressively explore more advanced and capable systems. The goal here is to help you develop a clear intuition and understanding about which kind of agent is appropriate for different scenarios. So when you're building your own agents, you will know exactly what structure makes the most sense for your specific use case. All right, let us jump in. Let's start with a very simple definition. An AI agent is basically a system that observes its environment using sensor and then take actions based on what it observes. But modern agents are more powerful than just observe and act. As they become more advanced, they gain additional capability that make them smarter and more useful. So in this particular part, we'll look at 5 important characteristics that define more sophisticated agents. First one, profile and persona, then memory, reasoning, actions, and learning capabilities. Now keep in mind, not every agent needs to have all these 5 to be considered an agent. Even having 3 or 4 of this can still qualify. But the more advanced agents typically include most or all of this feature. Let us start with the first one, that is profile and persona. This is essentially the agent's identity. It is usually defined in the system prompt. It describes how or who the agent is, what its role is, how it should behave, and why it exists. For example, you might define the agent as a marketing expert, a software engineer, or a SEO specialist. It can include things like communication style, tone of voice, and how it should interact with user. You can even define its values and guidelines and personality traits so that its behavior stays consistent. Then comes the memory. Memory is the information and context that the agent has access to. This could include like things like documents, knowledge bases, or example that help it to do its job better. For example, if you're building an agent to manage your company's social media, you might give it some brand guidelines, tone of voice documents, or examples of past posts that performed well. This helps the agent make better decisions. Then the third characteristic is the reasoning. Reasoning is the agent's ability to think using the available information to analyze situations and draw conclusions and solve problems. Generally, the stronger the underlying model is, the better the reasoning capability. Fourth is actions. Actions are how the agent actually interacts with and changes its environment. These are the concrete steps that it takes to achieve its goal. For example, a social media agent might generate a post and publish it on Instagram. That action directly affects the environment because users can now see that post in their feed. And finally, we have the learning capability. Learning allows the agent to improve over time. It can observe the results of its action and adjust its future behavior accordingly. For example, the agent can monitor engagement on its post, like comments and shares, and use that feedback to improve future posts by changing the timing and content and style. Basically, to summarize, the five key traits are profile and persona, memory, reasoning, actions, and learning. But now we'll look at different types of agents and see how these traits actually showed up in each of them. First one that we have to talk about, or the first type of agent structure, is simple reflex agent. As the name suggests, it is the most basic kind of agent. It simply reacts to what it perceives right now in the current moment. There's no thinking about past or no planning for the future. It just observes and immediately responds. Importantly, it does not have any internal memory or complex reasoning model. It does not remember anything and it does not try to analyze pattern. It just follows predefined rule. A very relatable example again is thermostat. A thermostat's environment is the surrounding temperature. It uses sensor to continuously measure the temperature, but it's not connected to any intelligent reasoning system. Instead, it just follows a simple conditional rule. If the temperature falls below 20 degrees centigrade, it turns on the heater. Here, the heater acts as the actuator, meaning it is the component that allows the agent to influence or change its environment. The thermostat's goal is again to maintain a fixed temperature. However, it has no ability to learn or improve. For example, it cannot figure out when the electricity is cheaper or adjust its behavior based on usage pattern. It will respond in the exact same way every single time the same condition occurs. This makes it a classical example of an agent because it senses the environment and takes action. But it is not an intelligent agent. It does not learn, it does not adapt, it does not reason, and it simply follows hard coded rules without getting any smarter over a period of time. And that brings us to the next type of agent, that is model based reflex agent. Now, just like simple reflex agent here, this agent observe this environment and take actions based on what they perceive. But there's one important upgrade here. Unlike simple reflex agents, model based reflex agents have memory. They don't just react blindly, they maintain an internal representation or a model of the environment. In other words, they build a mental picture of what the world around them looks like. A very relatable example is a robot vacuum cleaner. It moves around, cleans your room. It does not, however, just wander randomly. It actually creates a map of the space, identifying walls and furnitures and obstacles and open areas. Using this kind of internal map, the robot knows which areas are already cleaned, which areas still need attention. It also uses this information to avoid getting stuck or repeatedly cleaning the same spot. So the question arises, is this an AI agent? Well, yes, it is. However, model based reflex agents considered a basic form of AI because it uses an internal model to better understand and interact with the environment. This model helps it make more informed decisions compared to the simple reflex agent. But it's important to understand that it is still a limited form of AI. Why? Because the robot is not truly learning from experience. Its internal model is actually usually updated using predefined rules and sensor inputs, not through adaptive learning. It does not analyze past performance and improve its strategy over a period of time. It simply keeps tracks of what it has seen and updates its internal state accordingly. I know the distinction here are feel may feel a bit subtle, so bear with me. The key point here, however, is that the robot is remembering but not learning. For example, imagine a more advanced vacuum cleaner that notices over a period of time that your kitchen gets dirty much faster than your hallway. A truly learning agent would then recognize this pattern and start prioritizing the kitchen in future cleaning cycles. It would adapt its behavior based on experiences. But a standard model based reflex agent does not do that. It follows fixed logic. It maintains a model, but it does not evolve over time. It does not evolve its strategy. So, to summarize, model based reflex agents are smarter than simple reflex agents. However, they lack true learning and adaptation. Again, that was a quick introduction to model based reflex agent. Let us now move on to goal based agents, where things start getting even more interesting. Now, whenever you use a Google map or Waze or any other map, what it is really doing behind the scene is comparing multiple possible routes and estimating how long each one is going to take. Let us say something unexpected happens. Maybe a car breaks down or traffic suddenly builds up on the route it originally suggested. Now the situation has changed. At that point, the app starts receiving new information from the live traffic data and sensors. Its internal model processes this updated information and re-evaluates the available options to figure out if there's now a faster way to reach your destination. Remember, the core objective of the system is very clear: minimize your travel time. So naturally, if it finds a better alternative, it updates its recommendations and suggests a new optimal route. This is a perfect real world example of a goal based agents. These agents don't just react blindly. They actually think ahead. They evaluate possible sequences of actions and choose the one that best helps them achieve their goal. This kind of planning and research and searching capability was not present in simple reflex agents or even basic model based agents. That is why the goal based agents represent a more advanced level of intelligence. However, there's a trade off. Goal based agents are laser focused on achieving their objective, sometimes at the expense of practical consideration. For example, Google Maps might even suggest a very narrow road, or a poorly maintained lane, or a route that is technically faster but uncomfortable or inconvenient to drive. So, while the agent succeeds in optimizing the goal, reducing travel time, it may still miss the factors related to comfort or safety or overall driving experience. That brings us to the next type of agent that we'll talk about, that is utility based agent. Compared to the goal based agents, these are more sophisticated, and the reason is simple. Instead of just asking, did I achieve the goal or not? Utility based agents ask a deeper question: how good is this overall outcome? So they don't just look at whether a goal was achieved, they look at multiple factors and evaluate the overall usefulness, or what we call utility. Let us take an example to make it clear. Suppose your goal is to invest in financial securities that give more than 5% annual return. If an agent simply finds investment above 5% and selects them, that's the classical goal based approach. Goal achieved, done. But in real world, things are not so simple. A good investment advisor would not just look at the result, they'd also consider factors like volatility, how much the prices fluctuate, liquidity, how easily you can buy or sell it, or default risk, the chances that the issuer fails to pay back. All these factors affect how attractive the investment really is. For example, imagine one security offers a 7% return, and that sounds great, right? But suppose it's highly volatile, hard to sell quickly, and has a significant risk of default. Now compare that to the another security offering 6% return, maybe slightly lower, yes, but it is more stable, easier to sell, and much safer. In practice, the second option might actually be a better choice overall. And this is exactly what utility based agents do. They evaluate the trade offs, they consider multiple criteria at the same time instead of just focusing on one number or one goal. Technically speaking, their decision making is based on something called as utility function, which assigns a value to different possible outcomes. The agent looks at all the possible actions, estimate their expected utility, and then chooses the one with highest overall utility. So instead of just asking, did I reach the goal? A utility based agent asks, which option gives me the best overall outcome? And that is what makes them much more practical and powerful for real world decision making. Learning agents can do everything goal based and utility based agents can do. But what really sets them apart is their ability to learn from experiences. As they interact with the world, they don't just really act, they also update their knowledge. Every new experience gets added to what they already know, which helps them handle unfamiliar situations better and make smarter decisions over time. Just like other agents, they still have the usual component, the environment, the sensors to observe it, an internal model to represent it, decision logic to choose the action, and actuators to actually execute those actions. But on top of that, they also include a learning element. The learning element continuously improves the internal model using feedback from the past actions and outcomes. Because of this built-in learning capability, the agent can refine itself automatically. It does not stay static. It adapts and improves and become more effective the more experience it gains over a period of time. Earlier, I briefly mentioned about how AI agents actually learn and build their capability. This is a core concept, so we are going to slow down basically here and explore it properly over a next couple of slides. We'll start by looking at how AI agents gain knowledge by connecting to different external sources, things like databases and tools and APIs and documents. So they are just not limited to what they're trained on. After that, we'll talk about how human knowledge gets integrated into agents, how we can guide them, structure information for them, and essentially teach them to perform useful tasks. By the end of this particular part, you'll have a clear understanding of how agents learn and how you can use that understanding to unlock their full potential and build more powerful AI systems. As I discussed earlier, AI agents can make decisions on their own, but they don't operate in isolation. They still rely on humans to define their goal. This idea is captured by an important concept that is human in the loop, or HITL. It basically means humans stay involved throughout the entire life cycle of an AI agent, from training to deployment to continuous improvement. But let us understand this with a very simple example: a chatbot customer support chatbot rather. First comes the development stage. Imagine a tech company building this chatbot. Human developers are responsible for training it. They choose and prepare the training data, design the algorithm and architecture, and define the ethical rules and constraints. They also decide what success looks like. For example, if the goal is to improve customer satisfaction, humans define measurable metrics like satisfaction scores or resolution rates. Next comes the deployment stage. Once the chatbot is delivered to a client company, humans are still actively involved. Their employees integrate the chatbot into their workflows and guide its behavior through instructions and updates. For instance, support teams regularly update the chatbot's knowledge base with new policies, product updates, or company specific procedure. And then comes the production stage, where the chatbot starts interacting with real user. This is where continuous improvement happens. Human reviewers monitor conversations, analyze performance, fix mistakes, and refine responses. Even end users play a role here. They provide feedback indirectly through their questions and reactions and satisfaction levels. All this human input acts like a feedback loop that helps the AI agent learn, adapt, and perform better over time. However, there's a trade off. Human feedback is extremely valuable, but it is also slow and inexpensive to collect. Reviewing conversations, labeling data, and refining behavior takes significant time and effort. Still, this process is essential because it helps the AI agent learn from real world interactions and gradually become more accurate and useful. One of the coolest things about AI agent system is that they don't actually stay the same. They can learn and get better over time. And they mainly do this through three key sources. First, by learning from other agents. Second, by connecting to external sources like internet or databases. Third is through feedback from humans. We'll focus on how agents learn from external sources, including AI agents and information systems like the web. Then we'll look at how human interaction helps agents improve. All right, let us start with one really powerful idea: agents learning from other agents. This becomes especially useful when multiple agents are working on the same kind of task. Instead of every agent figuring everything out from scratch, they can share what they've learned from each other. This kind of agent to agent feedback reduces how much humans need to step in and guide them. For example, imagine a company using multiple AI customer support agents across different regions. Now, suppose one agent encounters a brand new issue, something it has not seen before. It interacts with a user, figures out the solution, and resolves the problem. Once it learns the solution, it can share that knowledge with other agents. So the next time another agent encounters the same issue, it already knows what to do. It does not need human help. It can immediately provide the correct solution. This kind of collaborative learning makes the entire system faster, smarter, and more efficient over time. Now, another major way agents learn is by connecting to external information sources. These sources can include datasets, web searches, APIs, or any external system that provides useful information. When an agent realizes that it does not have enough information, it can use these tools to fetch what it needs, update its knowledge, and then continue reasoning. Let us take a very simple example. Suppose a user asks an AI agent to recommend the best week next year to go surfing in Greece based on the weather conditions. Now, the agent's core language model may not have detailed or up to date weather expertise. So, the agent connects to an external weather database and retrieves historical weather data for Greece. But weather alone is not enough. The agent still needs to understand what conditions are ideal for surfing. So it performs another step. It searches surfing websites or APIs to learn that the best surfing condition usually involve high tides, sunny weather, and low rainfall. Now the agent combines both pieces of information, weather data plus surfing knowledge, and identifies the pattern. Based on that, it can predict which week next year is most likely to offer ideal surfing condition. It then presents this recommendation to user. And this highlights one of the key differences between AI agents and traditional AI tools like ChatGPT. Agents don't just rely on what they are trained on. They can actively fetch new information, learn from it, and use it to make better decisions. This ability to continuously learn and share knowledge makes AI agents far more dynamic, adaptive, and general purpose compared to static AI agents system with fixed knowledge. Now that we have built a strong foundation, we are ready to move into practical side of AI agents. In this section, we'll clearly separate out three concepts that often get mixed up: LLMs, AI workflows, and AI agents. We'll introduce two important frameworks used to build agents, that is React and Revu, and understand how they help agents understand and act effectively. Along the way, we'll compare single agent and multi-agent system, explore powerful idea of chain of thought reasoning, basically how agents think step by step, which not only improves their decision but also make their behavior easier for developer to understand and debug. Let us get going. I hope you're excited, but this is where things get really, really interesting. Let us start with very simple question. Is ChatGPT an AI agent? Or if you build an app that connects to an LLM, does that automatically make it an AI agent? And what exactly is difference between an LLM, an AI workflow, and an AI agent? If this feels a bit confusing right now, that's completely normal. I felt the same way initially, but by the end of this particular section, everything will be much more clearer. You have probably used ChatGPT many times now. At this core, it's a chat interface powered by LLM that the way that LLM works is straightforward. You give it a prompt, a question, or an instruction, and it generates a relevant response. But here's the key point: the LLM only responds when you ask it to. It does not act or it does not take initiative or act on its own. For example, if you ask ChatGPT to translate a sentence, it will translate it, but that's it. It won't do anything else unless you give another prompt. Now imagine asking ChatGPT that translate my latest email. Can it do it? No, because it does not have access to your mail. LLMs operate only within the information provided in the prompt and knowledge they were trained on. They don't actually fetch new or private information. Everything happens inside the boundary that we have defined earlier. Now, let us move on to the next step and talk about AI workflows. Suppose you build an app that connects to your email. When the user clicks a button, the app retrieves the latest mail, sends it to the LLM for translation, and then shows the translated result. This is an AI workflow. You are connected to LLM with external tool, in this case an email, and create a sequence of steps to complete a task. But notice something important: the workflow is still fixed. It only runs when triggered. It follows a predefined path designed by a human. The system does not decide what to do, it simply executes the step that it was programmed to follow. And this is where AI agents are fundamentally different. An AI agent is goal driven. Instead of following a fixed script, it figures out the steps on its own. It can access the tools like emails and calendars or the internet and decide how to use them to achieve its objective. For example, if the goal is to respond to an email about scheduling a meeting, the agent can read the email, understand the intent, check your calendar for availability, and suggest a suitable time, all without you specifying each individual step. It can even consider additional context like location or weather to make better decision. And if allowed, it could send the reply automatically. What makes this powerful is that the agent reasons about what needs to be done instead of just executing a fixed sequence. Another key advantage is learning and adaptation. Over time, the agent can remember your preferences. For instance, if you don't like a certain meeting location, it won't suggest it again. The more it interacts with you, the better it becomes at assisting it to you. So summarizing all this thing: an LLM responds to prompt, an AI workflow connects an LLM to tools but follows fixed logic. An AI agent uses reasoning and tools and autonomy to achieve goals dynamically. This distinction is the foundation of everything that we are building next. Setting up an in person meeting actually takes way more effort than most people realize. Here's how it goes usually: your business associate suggests catching up in person. So you open up your calendar, look for some free time slots, and then send those options over. She then picks one that works and then say, where should we meet? Now you check your schedule again and realize that you'll be working from home that day. So the meeting spot needs to be somewhere nearby. You think of a nice outdoor cafe, maybe, sounds perfect. But then you remember it was pretty crowded the last time you went there. So you're not really sure about whether you'll get a table there. So now you either call them or check their website to see if the reservations are possible. And if they do not allow for reservation, you need to find a backup place. Only after all this back and forth, you do finally confirm the meeting. So as you can see here, the point is this whole process takes time and mental effort. And honestly, most people would rather focus on more important work. This is exactly where AI agents comes in. At each step, a specialized AI agent can think through the situation, gather the required information, and take the next action automatically. It can figure out the best time by connecting to your calendar and suggesting available slots. It can determine the meeting location by checking whether you are working from home or the office. If you are working from home, it can find nearby meeting spots and even consider your preferences like indoor versus outdoor sitting. It can check the weather forecast online. It can call the cafe using a voice enabled model and reserve a table. And once everything is confirmed, it can send the calendar invite and notify everyone. Notice the pattern here. The agent first thinks what needs to be done, that is reasoning. Then it performs the action, that is acting. This continuous cycle of reasoning and acting is why this framework is called React. The model evaluates the situation, decides the best next step, and executes it. But what if the model did not follow this reasoning and acting loop? That is what we'll explore next. That is the next important framework is REVU, which stands for reasoning without observation. In simple terms, with REVU, we tell the agent to think through and plan everything in advance. It decides all the steps upfront without letting tool outputs influence its planning later. So once the plan is made, it sticks to it. Now let us compare this with React using the same example that we discussed earlier. So with React, the agent works step by step. It reasons about what to do next, uses a tool, looks at the output, answers the immediate question, and decides the next step based on that new information. For example, if the agent does not know where you are working from, it might check the HR Planner tool first, get that information, and then decide which cafe to check. The reason this reasoning cycle keeps repeated throughout the process. With Rebu, however, the approach is different. The agent first sits down and plans the entire sequence from the start to finish before taking any action. It does not pause midway to gather new information or change direction. So, in our example, in with Review agent, it would first create a complete plan, check your calendar, confirm your work location using the HR planner, verify the cafe's availability, and even identify a backup option. Only after this full plan is ready does it begin execution, and it does follow the plan exactly as defined. One advantage of this is focus. For instance, if the cafe's website shows ad or special offer, a React agent might get distracted and spend time exploring irrelevant information. The review agent, however, on the other hand, it will ignore all that, and it says strictly on track. However, this also makes a review less flexible. If something unexpected happens, like cafe being fully booked, the review agent cannot easily adjust because it is already committed to its original plan. So overall, React is more adaptive and flexible, while review is more structured and disciplined. Both approaches are useful, and the right choice really depends on the type of AI agent and the environment that it is operating in. Whenever we talk about AI agents, one of the first thing to figure out is whether we are dealing with a single agent system or multiple agents are working together. Let us focus on single agent systems first. These are much simpler to design, easier to manage, and honestly the best place to start when you want to build something clean and efficient without unnecessary complexity. Now, just because there's only one agent does not mean it is limited in any way. In fact, it can be extremely powerful. Every time you give that agent access to a new tool, its capability expand. It can do more, automate more, and solve more complex tasks. Another big advantage of using a single agent is that it makes things easier to evaluate, debug, and maintain. You don't have to worry about coordinating multiple agents on figuring out which one caused an issue. Think back to the example of a personal assistant that can reply to emails, book meeting rooms, and schedule meetings at the right time. Even though it is handling multiple tasks, it is just one agent using different tools. That's a classical example of a single agent AI system. This is the basic structure of a single agent system, and we'll break down each of this component and understand roles in few sides. But before that, it's important that we also understand the other side of the spectrum, that is multi-agent system. Now, when you're working in a team, you don't expect everyone to do everyone else's job, right? Let us say your company wants to redesign its website homepage. You typically have a graphic designer handling visuals, a copywriter working on text, a marketing specialist thinking about positioning, a brand manager ensuring consistency, and maybe an SEO expert optimizing for search. When each person focuses on specialty and collaborates properly, the final outcome is much better than one person trying to do everything. The same principle applies to AI agents as well. Instead of relying on one agent, you can have multiple specialized agents, each designed to handle a specific responsibility. Each agent brings its own strength, which makes the overall system more capable. But there's a trade off here. As you add more agents, the system becomes more complex to design, manage, and coordinate. To make this work effectively, you need orchestration, basically, a way to organize how agents collaborate within the workflow. Behind the scenes, agents use tool calling to fetch up-to-date information, optimizing their decision, and even break down the task into smaller subtasks automatically. How you structure your agent matters a lot. Broadly, there are two approaches. The first is manager structure, where there's a central manager coordinating everything. This manager assigns a task to specialized agents and ensure things stay on track. Interestingly, this manager could either be a human as well, guiding the process, or another AI agent as well, acting as a coordinator. The second approach is decentralized structure, where agents work more like peers. There's no central manager here. Instead, agents pass tasks to each other based on their expertise. Each agent knows what it is good at and steps it needs to perform. One big advantage of using multiple agents is reliability. Agents can review each other's work and provide feedback and catch mistakes, which improves overall accuracy. That said, it is usually best to start simple. Begin with a single agent, fully utilize its capability. In many cases, one well designed agent with right tools is enough to handle even more complex workflows. You should consider adding more agents when the tasks become more complex, when the agent struggles with the instructions, or when specialization can clearly improve performance. Breaking work into smaller, well defined responsibilities often make the system more scalable and easier to manage in the long run. So far, we have put together a really strong base. You now understand the core building blocks that make up an AI agent system. We've also looked at different types of agents, how they vary depending on what they're designed to do and how capable they are. On top of that, we also explored how agents actually learn and went through some of the most important designing patterns that make agents effective and reliable. So, yes, we are moving in the right direction. Now, in this particular part, I'm going to shift gears a bit and focus more on hands-on, practical side of building and working with AI agents. Specifically, you will see how to choose the right model for your agent, decide which tools it should have access to, set up clear and effective prompt instructions, and implement the right guardrails to keep everything safe and under control. Sounds good, right? So let us dive in. Now that we have understood what agents are and how they work, the next logical question is, how do we actually bring them to your business? The first step is to get really clear on your objective. What exactly do you want the AI agent to do for you? Are you trying to improve customer satisfaction by offering 24 by 7 support? Or are you aiming to reduce operational cost by automating tasks that humans currently perform? When you have a clear goal, everything else becomes much easier. You can define a proper roadmap, and more importantly, you know what success looks like. Once that is clear, the next thing that you have to think about is data. AI agents are only as good as the data they have access to. You need high quality, reliable data flowing from your internal systems so the agent can learn properly and access the right knowledge when needed. Without good data, even the best designed agents won't perform well. Now, before we start building, it's also important to visualize the process and decide what kind of agent you actually need. For example, if you're building a simple chatbot to answer customer questions on your website, a basic reflex agent might be enough. If you want something more advanced, like an agent that can analyze your latest offers, compare them with competitors, and highlight your advantages, then you will need a learning agent that can adapt and improve over time. You'll also need to make sure your internal systems can provide the agent with all the information that it needs. Once you build and working prototype, the focus shifts to your user experience. You observe how people interact with the agent, identify gaps, and refine its behavior and instructions. After deployment, monitoring becomes critical. You need to track performance and ensure the agent is meeting your KPIs. But don't just rely on metrics. Human oversight is still very, very important. AI agents can operate independently, but there will always be a situation where human judgment is necessary, especially for complex and sensitive scenario. So overall, implementing AI agent is not just about building the technology. It's about defining clear goals and providing the right data, choosing the right type of agent, refining based on user interaction, and continuously monitoring the performance. Now, there are tons of language models out there, dozens of major ones, and honestly, hundreds and thousands of many more that are useful depending on the situation. So, naturally, the big question is, which one should you pick to run your AI agent? Should you always go for the smartest, most powerful model available? Well, not really. As cliche it sounds, the real answer is it depends. Every model has its own strengths and trade offs. Some models are incredibly powerful and can handle complex reason and nuanced decisions, but they tend to be slower and more expensive. On the other hand, some models are extremely fast and cheap, but they might not perform well on more challenging tasks. And that is why it is usually a good idea to keep trying multiple models before deciding which one works the best for your use case. Also, not every task actually need the most advanced model. For simpler things like answering frequently asked questions, routing queries, or detecting user intent, a smaller, faster model is often more than enough. But when you are dealing with more critical or complex decisions, like deciding whether a customer is eligible for a refund, evaluating applications, or making decision judgment based decisions, that is where more capable models really shine. A more practical approach that many teams follow is that start by building your model using the most capable model. This gives you a strong performance baseline. Once you know what the good performance looks like, you can then start experimenting with faster or cheaper models and see if they still meet your quality requirement. If they do, great. You have made your system more efficient without sacrificing much performance. But at the end of the day, choosing the right model is always a trade-off. You're always balancing accuracy, speed, cost, and scalability, and all those stuffs. And the right choice depends on what matters most for your specific application. Agents, they don't work in isolation. They need tools to talk to other software. Most of the times this communication helps or happens through APIs. You can think of APIs as bridge that connects agents to external systems like databases and CRMs and search engines or any other software that they need to interact with. Now, if an API is not available, agents can still interact with software the way human do, by navigating interfaces, clicking buttons, or reading web pages. But honestly, that is not ideal. Even for humans, browsing a website to find specific information is slower and more error prone compared to getting clean structured data in a table or JSON format. The same applies for agent as well. Structured access is always more reliable and accurate. Broadly, agent tools falls into two categories: data tools and action tools. Data tools help retrieve information. For example, an agent might use a data tool to look up the customer details in a database, reading information from a PDF, or search the web for a relevant content. All of these tools serve one purpose, that is helping the agent gather the information it needs to make decisions and carry out its task. Action tools, on the other hand, allow agents to actually do things. This could include scheduling meetings, creating customer support tickets, processing refunds, or updating records. These tools let agents modify their environment and move closer to completing their goals. So, in simple terms, data tools help agents know things, and action tools help agents do things. Now, you probably already know how important prompt engineering has become when working with large language models. But honestly, just a few years ago, hardly anyone was even talking about it. Now, it is one of the most essential skills that you really want to get the best results out of AI. At its core, it's pretty simple. The clearer and more specific your instructions are, the better the output will be. When you reduce ambiguity, the model does not have to guess what you mean. It just does exactly what you want. And this same idea applies directly when you are building or working with AI agents. Whenever you create an agent, one of the most important things you will design is the system prompt. Think of it as a agent brain or operating manual. A well crafted prompt helps the agent make better decision, execute workflows more smoothly, and avoid unnecessary errors. Now, OpenAI has shared some really useful best practices for writing writing agent instructions. One of the first recommendation is to use existing documentation to create a LLM friendly routines. In other words, build a solid knowledge base. When your agent has access to structured, relevant information, it can provide much more accurate and useful responses because it actually has the right context. Another key practice is to encourage the agent to break tasks into smaller steps. This makes the reasoning process easier for the model and also reduces the chance of hitting context limits or making logical mistakes. Step by step thinking leads to more reliable outcomes. It's also important to define actions clearly, avoid vague instructions. The more explicit you are, the less room there is for misinterpretation. For example, instead of saying something general like help the customer with their order issue, you should specify exactly what you want it to do, like asking for order ID, checking delivery status, and offering a resend or refund if needed. Clear instruction lead to consistent behavior. Another thing that you should always think about is edge cases. Of course, you won't be able to predict everything before deployment, but more scenarios you anticipate upfront, the better user experience will be. For example, if someone asks for a refund after the return window has expired, your agent should not get stuck. Instructed to politely explain the policy and offer alternatives like store credit or exchange or something like that. All of this come together to create a reliable effective system prompt. When done right, your agent becomes much more predictable, more helpful, and more easier to trust. We'll look at some powerful prompting techniques that can make our agents even better. Chain of thought reasoning and few shot prompting. Before I talk about chain of thought, I want to talk about zero shot and one shot and few shot prompting. If you're not already aware of this, don't worry, we'll break down in this particular part. Let us start with zero shot prompting. Zero shot prompting simply means asking an LLM to do something without giving it any examples. So you just describe the task and model uses its existing knowledge to figure out what to do and generate a response. Think of it like imagine you just got hired as a sales representative. On your first day, no one trains you, no one shows how things work. You just told to start helping the customer. You have to really rely entirely on your past experiences, instincts, and communication skills. That is exactly what zero shot prompting is. The model is doing the task based purely on what it already knows. Then comes the next is one shot prompting. Here you give the model the instructions along with one example. So going back to the same analogy, this would be like your manager serving one customer in front of you so that you can observe how it is done. And after that, they leave and now it is your turn to do whatever he has done. That single example helps guide your behavior. And lastly, we have few shot prompting. This is when you provide instructions along with a smaller number of example, typically between 2 to 10. In this case, your manager helps several customers while you watch. You get a better sense of pattern, the tone, the approach before you handle the customer on your own. Naturally, with more example, your performance becomes much more consistent because you know things better. Anything beyond this moves into territory of fine tuning. Fine tuning is not just showing you the examples, it is more like fully training someone. Imagine your manager spending weeks training you, doing role plays and correcting your mistakes and giving detailed feedback and refining your sales pitch. Over time, this structured training, deeply shapes how you perform. That is similar to a fine-tuning a model. It modifies the model itself rather than just guiding it through prompts. So I hope this analogy maps gives you a good idea on how things map directly to AI agents. Just like a sales representative perform better with proper training, and AI agents effectiveness depend how much guidance you provide, whether that's zero shot, few shot, or full fine tuning. Choosing the right approach ensures your agent behaves reliably and produces accurate results in real world scenario. Then comes the chain of thought. Now, chain of thought is a prompt engineering technique where we ask the AI not just to give the final answer, but also to walk us through its reasoning, the intermediate steps it used to reach that conclusion. For example, suppose you ask an LLM, which is the best month to visit Greece if I like beaches, but I'm on a budget. It simply says September. Now that answers the question, but it does not tell you why September is the best choice. With chain of thought reasoning, the AI explains its thinking. It might say something like, if you enjoy beaches, the suitable months in Greece are May through September. However, June, July, and August are the peak tourist season, so prices are much higher. That leaves May and September as more budget friendly options. Between those two, September usually has more consistent sunny weather compared to May, so overall, September becomes the best option. So, you see, instead of just giving the right answer, the model shows its reasoning step by step. Now, why this is useful, especially when designing AI agents? Researchers have found out that agents perform much better when they explicitly reason through problems, particularly complex ones. It helps them break tasks into smaller logical steps rather than guessing the answer correctly. Another big advantage is transparency. When an AI agent explains its reasoning, engineers can actually see how it arrived at a decision. This makes it much easier to debug the system. If something goes wrong, you can pinpoint exactly where the reasoning failed and you can fix it. In short, chain of thought makes AI agents more reliable, more understandable, and easier to improve. Well, then brings me to this very kind of unusual question, that why do roads have guardrails? Simple, they stop cars from going off the edge, especially in risky areas like sharp turns and cliffs. They reduce the chance of a serious accident. But guardrails alone are not enough. We also have speed limits. They control how fast vehicles can go, which lowers the risk of losing control. Traffic lights help coordinate movement so vehicles don't crash into each other at intersections. Road signs warn drivers about upcoming dangers, giving them time to slow down or adjust. In other words, road safety is not just dependent on one thing. It's created by layering multiple safety mechanisms, each solving a different kind of task. One layer helps, but multiple layers working together make the system much safer. Why we have discussed that? Because AI agents work the same way. When we deploy AI agents in real world applications, we need guardrails to reduce risk and ensure safe, reliable behavior. For example, one major concern is information security. An AI agent might accidentally expose sensitive or confidential data if proper safeguards are not in place. Another important aspect is brand alignment. The agent should communicate in a way that reflects the company's tone and values and professionalism. If it does not, it could damage the brand's reputation. Accuracy is another area where guardrail matters. They help reduce hallucination and prevent agent from giving incorrect or misleading information. Just like road safety comes from combining guardrails, signals, and signs, AI safety comes from combining multiple guardrails designed for different risks. Together, they create agents that are safer, more reliable, and more trusty. And this is not just a one time setup, or as the agent gets used in real world scenario, you will see that new edge cases and risk comes along. That is when you add more guardrails and refine the existing ones, and thereby it is a never ending ongoing process. However, The Open AI team suggests a few key principles in mind. First, always prioritize data privacy and content safety. And second is to learn from real world failures and add guardrails accordingly. The third is to strike the right balance between safety and user experience. The goal here is not to restrict the agent unnecessarily. It is to make it resilient and dependable and ready for real world use. One important safeguard, however, that we have not talked about yet, especially when you're launching an AI agent, is human intervention. This becomes very critical in early stages when you are deploying the agent for the first time. At that point, you cannot just blindly trust the agent. You need humans in the loop, reviewing its outputs, validating its responses, and making sure it's actually behaving the way you expect. The reason is simple. Humans have intuition, context awareness, and make sense or common sense that automated tasks just don't fully replicate. We can quickly spot when something feels off, whether it is subtle mistakes, a weird edge case, or a response that is technically correct but practically useless. These are just kind of issues that often slip past automated evaluation. So human oversight becomes a powerful feedback loop. It helps you catch hidden problems, understand failure patterns, and continuously improve the agent. You can even design your system so that agent actively involves humans when it's uncertain. For example, in a customer support scenario, the agent can escalate the conversation to a human perspective, and in something like a coding assistant, the agent can hand control back to the user when it is not confident about solution. So the key idea here is that the AI agent should not operate completely on their own, especially in the beginning. Keeping humans in the loop makes the system safer, more reliable, and much easier to improve over time. But let us now talk about to basically check the AI agents. In simple terms, we are trying to answer this very basic question: what actually makes an AI agent good or effective? It sounds straightforward, but once you think about it, it is not actually that simple. For example, is a good agent the one that responds quickly? Sure, speed matters, but what if those fast responses are wrong? That is obviously a problem. Okay, then maybe a good agent is one that is polite or follows ethical guidelines. That is important too. But what if it cannot solve the task that it was built for? Then politeness alone cannot make it useful. So clearly, there's more to it. A truly effective agent needs to balance multiple factors like accuracy and speed and coherence and cost and safety and several other things. And the tricky part is that the importance of each of these depends on the agent's purpose and where it's being used. For instance, if you look at the customer service chatbot, its top priorities would be coherence and safety. It needs to communicate clearly, avoid harmful response, and maintain a good interaction with the users. But if you consider something like an automated trading agent, the priority shift. In that case, accuracy and speed is the far more important part. It becomes critical. The agent needs to identify opportunities correctly and act quickly. Otherwise, it simply won't be effective. Another important factor that often gets overlooked is the user experience. Let me give you a real world example for this. An AI agent or AI developer, built a real estate chatbot that provided highly accurate responses using structured listing data. Technically, everything was working perfectly during testing. The answers were correct and the system was functioning exactly as intended. But there was a problem. User did not trust it. Interestingly, the issue was not accuracy. It was the way the chatbot communicated. Its responses felt robotic and repetitive. One user even joked that it felt like a bureaucrat trying to sell a house. There was not any standard metric that captured this issue, but it had a real impact on how users perceive the system. The fix was not improving accuracy. Uh, Instead, the developer focused on improving tone, memory, and context awareness. Once the chatbot felt more natural and conversational, User engagement improved significantly, and that highlights an important lesson for us. Metrics are important, but they don't tell the whole story. User experience often reveal the issues that numbers alone cannot capture. Evaluating AI agent is a critical step when building and deploying them. In most cases, you won't get everything right on the first try. You will need to iterate and analyze performance and continuously refine the system. Data and metrics will help you identify strengths and uncover weaknesses, but at the same time, the real world feedback and user interactions are the most important, because in the end, a truly effective AI agent is not just accurate, it is also reliable and useful and trusted by the people who use it. Well, we are doing actually quite well. If you think about it, we have covered a huge amount since the start of this series. We began with the basics, understanding what AI agents actually are and why leaders at major tech companies are so excited about them and see them as future. Then we built a strong foundation. We learned what components are needed to build AI agents, the different types of agents that exist, and how you can train them and shape their behavior. We also went deep into most important design patterns and talked in detail about how to actually implement AI agents in the real world scenario. Again, that is a seriously impressive progress so far. But now, in this particular part, I'm going to shift our focus to something that is really equally important: the infrastructure around AI agents. In other words, everything needed to actually build, run, and deploy them in the real world. We'll talk about APIs, cloud platforms, knowledge integrations, and how to deploy our agents so that they can operate reliably and at the scale. At this particular part, I hope you'll have confidence to not just build the AI agents, but also set them properly, manage them, and scale them when needed. Let us do it. Well, one of the first practical questions that come up when integrating AI agent into business is this: should you build your own AI model or you should use an external one? This is classic make versus buy decision. In reality, only a small number of organizations have the resources, expertise, and infrastructure required to build their own large language models, the core intelligence behind an AI agent. Because of this, the most organizations choose to use external models and simply pay for access. So the next question is, most uh, how do you actually connect an external LLM to your AI agent? Thankfully, it is much simpler than it sounds. This is where APIs come in. In an API actually acts like a bridge that allows your agent to communicate with an external model. The first step is choosing a provider. This could be OpenAI, Google, Anthropic, or another LLM service. When choosing, you'll typically consider factors like speed, accuracy, reliability, cost, etc. Once you have chosen a provider, you integrate their API into your application. From that point onwards, your agent can send prompts to your external model, receive responses in real world, and use those responses to decide what to do next. You can think of it like your agent is outsourcing the thinking to a highly powerful brain running in the cloud. This approach allows you to build powerful AI agents quickly without needing massive infrastructure or investing millions into training your own model. Saying that AI agent needs a lot of compute would honestly would be an understatement. As your agent becomes more capable and starts handling more tasks, its compute requirements increase significantly. More reasoning, more tool usage, more requests, all of that translates directly into your higher demand for GPUs, memories, and overall infrastructure. So if you're running a business, this essentially becomes a classic make versus buy decision. If you choose the make route, you will need to invest in your hardware, powerful GPUs, servers, and storage, and make sure it is capable of handling peak workloads. The challenge here is that you are paying for maximum capacity upfront, even though you might not use it fully at the time. On the other hand, we have the buy route, means relying on external cloud provider. This gives you flexibility because you don't need a huge upfront investment. You can scale your compute up when your agent is busy and scale it down when it is not, and you only pay for what you actually use. This is exactly where the cloud platforms shine. They give you scalable infrastructure so you can experiment and deploy and grow without worrying about managing physical hardware. This three major cloud provider, that is AWS, Microsoft Azure, and Google Cloud Platform GCP, all offer infrastructure specifically designed for AI workload. They provide access to powerful GPUs, large scale storage, ready to use APIs, and tools that make building, running, and scaling AI agents much easier. Imagine hiring a world class financial analyst and give them access to a company's ERP system. How much impact would they actually make? Not much, right? Or think about a top tier class sales team that doesn't actually know the product they are selling to. No specs, no details, no context. Their effectiveness would be very, very limited. This is what or how AI agents work. They perform at their best when they have access to right data. The more relevant information you give them, the smarter and more useful they become. In practice, this means connecting your AI agents to your databases, enterprise system, knowledge bases, or even the internet. Let us start with database. Database are where companies' core information lives. When you connect an AI agent to your database, it gains direct visibility into your business system, which helps it make much more advanced or informed decision. Similarly, connecting the agent to ERP is incredibly powerful. Your ERP contains detailed operational data like inventory and production schedules and financial performance and customer orders. With access to all of this, the AI agent get a complete 360-degree view of how your businesses operate. You can also connect the agent to internal knowledge bases. For example, companies policies. This ensures the agent behaves according to your organization's rule. You could also connect brand guidelines so the agent communicates in the correct tone and stays aligned with your company's voice. And finally, you have the agent that gives access to the internet. This allows it to use publicly available information, which adds broader context and improve its reasoning capability. So overall, the key idea is simple. The more relevant the knowledge your AI agent has access to, the more effective it becomes. All right, now that we have covered data and knowledge integration as well, let us move on to development framework. Modern AI agent projects almost never start from zero. Instead, they are built by combining ready made building blocks. Think of them like Lego pieces that let you easily add capabilities such as memory, planning, tool usage, orchestration, and others. So, in this particular part, we'll look at some of the most important frameworks that help you do exactly that. Let us start with LangChain. If you learn one framework, this is the one to pick. LangChain gives you two core components, that is chains and agents. Chains are used to build structured step-by-step workflows that we call agentic workflows, where the sequence of actions is predefined. For example, imagine an app that summarizes customer feedback. Every time new feedback comes in, the app follows the same step. Collect the feedback, send it to the model for summarization, and save the memory. That fixed sequence is essentially a chain. Agents, on the other hand, are more dynamic. They don't just follow a fixed script here, they can make decisions and adjust their actions based on new information. LangChain also provides built-in tools that makes it easier to create these intelligent agents. On top of that, we have the Lang graph, an extension to LangChain that uses when your workflow is not just a straight line. Instead of simple sequence, you can design a graph with multiple path and work well for everything from the simple chatbots to complex system with multiple collaborating agents. Next is Microsoft AutoGen, which is designed specifically for multi-agent collaboration. Here, you assign roles like researchers, coders, or reviewer, and the framework manages the conversation between them. This agent exchange messages, share context, and even make decisions together. Since it is built by Microsoft, it integrates smoothly with Azure and OpenAI services. This makes it especially useful for scenarios where different specialized agents need to work together on complex tasks. Another interesting framework is Crew AI. It focuses on organizing teams of agents in a simple and intuitive way. Each agent have their own role, a backstory, and specific goals, and the framework handles coordination and task delegation automatically. It also integrates with LangChain, so you get the benefits of that ecosystem without dealing with all its complexity. Crew AI again is great for collaborative scenarios, storytelling applications, or demos that are easy for non-developers to understand. Google's Agent Development Kit, or ADK, is another powerful option, especially if you're working with Google Cloud ecosystem. It connects directly with Gemini model, then Vertex AI and enterprise system like BigQuery and SAP. This framework is ideal for enterprise use cases where agents need secure access to internal data and must follow strict governance and security standards. Then there's Flowwise, which is perfect for beginner or anyone who prefers a visual approach. Flowwise lets you build agents using a kind of a drag and drop interface where each block represents a prompt tool or a prompt or tool or a agent. You don't need deep programming language here. It supports branching logic, human in the loop interactions, and development as an API or chat widget. It is specifically useful for rapid prototyping and experimenting with ideas. Of course, these are just few examples. New frameworks are coming out all the time. The goal here is again simply to give you a sense of what is available and how these tools help you build powerful AI agents more easily. Now, once you build your agent, the next step is deployment. Your agent might work perfectly in a notebook, but that is not where it belongs. It needs to be accessible to the user. Maybe you through a chat interface on your website, inside your product, or as a backend service running behind the scene. In most cases, deployment happens on the cloud. Platforms like AWS provide services like Lambda and Bedrock and SageMaker and Lex, which makes it easier to deploy and manage AI agents. While setup can be technical, cloud platforms handle scalability, reliability, and infrastructure for you. This ensures that your agent can interact with user rather smoothly and perform reliably in real-world environment. To really understand the value of AI agents, it helps to think about them as AI employees that companies can hire. They are not just human, of course, but they are increasingly capable of handling many of the same tasks humans do today. One obvious benefit people immediately think of is cost savings. If AI agents can do more work that employees traditionally handled, companies can operate more efficiently. In fact, CNN reported that around 41% of companies worldwide are planning workforce reduction by 2030. Typically, junior and less specialized roles are more likely to be affected first, while leadership and strategic roles are harder to replace. But the cost advantage is not just about salary. Human employees come with additional cost: onboarding, paid leave, health benefits, office space, laptops, and other perks. AI agents do not need any of that. They don't need desk and parking space or even company swags. So when you think about cost efficiency, it is not just about salary that disappears. It is the entire overhead around maintaining human employees. There's also an interesting difference in how costs evolve over time. Human employees usually become more expensive as they gain experience and as the company grows. With AI agent, it is almost opposite. There's typically a higher upfront investment to build and deploy them, but once they are in place, they can scale to handle more work with very little additional cost. They keep improving over time while remaining relatively inexpensive to maintain. This makes businesses far more scalable. Another big advantage is error reduction. When you automate certain processes, you reduce the chances of costly mistakes. Depending on the industry, this could mean less wasted material, fewer operational issues, and better customer satisfactions. Let's look at the revenue side, which is equally exciting. AI agents can take over repetitive, boring tasks that normally consume a lot of human time. This frees up employees to focus on higher valuable work, things like innovation, problem solving, and improving products. Creativity thrives when people have time to think, and AI agents help create that space. They can also significantly improve customer service. Even smaller companies can offer 24 by 7 support using AI agent. And in many cases, AI agents can provide more consistent and accurate responses because they have instant access to company policies, procedures, and knowledge. This is especially powerful in large organizations where no single human knows everything. One of the most exciting future possibilities is real time decision support. AI agents will be able to connect directly to company data and provide insights to decision maker. This will help leaders make faster, smarter decisions and run operations more effectively. The biggest value of AI agent is not just saving money or automating tasks, it's about amplifying human potential. They take care of repetitive work, provide insights, and allow humans to focus on strategy and creativity and innovation. The real future is not human versus AI, it is humans and AI working together, each doing what they do the best. No matter what your role is, whether you are writing code, handling customer support, or working in logistics, you will increasingly find AI agents working right alongside you. In the coming years, AI won't just assist you, it will actually observe how you work and learn from it. Gradually, it will start performing certain tasks faster and more efficiently than us human. That said, however, there will still be areas where humans clearly outperform AI. Let's be clear, virtual employees are becoming a reality. Companies will need to adapt and optimize their workflows to stay competitive. If they don't, someone else will, and they will gain the advantage. Routine, repetitive tasks, especially administrative work, are the easiest targets for automation. Roles that involve less critical thinking, fewer soft skills, and limited creativity are more likely to be handled by the AI agents. This means humans will need to shift their focus towards higher value work. Skills like intuition and creativity and judgment will become more important. Even in organizations that adopt AI heavily, humans will remain essential, especially for things like strategic discussions and decision making meetings and creative thinking and solving complex problems. In fact, most AI driven workflows will still have a human in charge, someone responsible for supervising the AI, reviewing its decisions, and stepping in when needed. Every AI system should also have clear escalation paths. For example, imagine you are talking to an AI support agent from a real world state company. The AI can easily answer factual questions like price, location, or square footage, but when you then you ask something more subjective, is this neighborhood good for a young family with kids? At this point, the AI recognizes that this requires human judgment and local experience. So it hands off the conversation to, let us say, Emma, a human agent who actually lives nearby. Emma can share real insights about schools and safety and perks and overall community vibe. This handoff ensures that the experience remains personal and trustworthy and genuinely helpful. It shows why humans and AI need to work together and not compete with each other. Another important responsibility for human managers is, for example, regularly reviewing AI decision. For example, maybe again, imagine a bank using an AI agent to evaluate small business loan application. The AI processes applications quickly and consistently, but the bank's loan manager, Alex, still reviews one of the AI's decision every single week. During one review, AI or Alex, let us say, notices the AI rejected a promising local businesses because of financial issues. However, Alex knows the business has strong growth potential and a solid local reputation, things the AI did not fully account for. So Alex steps in, approves the loan, and updates the AI guidelines so as to make it better decision in the future.